is a lecturer in Department of Information Technology, Anna University, Chennai. He finished his MCA from Urumu Dhanalakshmi College, Bharatidasan University. He finished his ME in Computer Science and Engineering from College of Engineering, Anna University. His areas of interest are multi-core programming and architecture, programming models, compiler, automata theory, cryptography, and algorithms. He is an expert in subjects like compiler design, formal languages and automata theory, analysis of algorithms. His research area is code generation for multi-core architecture.
Welcome to the UGC lecture series on computer science. We are having series of lectures on theory of computation. Actually, as far as the previous episodes are concerned, we are studying the Turing machines, how we are designing Turing machines as recognizers for different languages, and how we are designing Turing machines for computations, simple computations. So, those things we are studying as far as the previous episodes are concerned. Also, there are various varieties of Turing machines available or variants of Turing machines available. So, in terms of either the tape structure and that is like how many number of tracks available or how many number of tapes available. So, they are having different facilities, that is the different features of the Turing machines. So, one version of the Turing machine or one variant of the Turing machine we had seen in the previous episode is the Turing machines with multiple tracks. So, we had that is one tape, but there are more number of tracks available on the Turing machine. So, that we will be able to store, that is not only the input, also we will be able to that is have more number of symbols in parallel with the tape content. So, we can have any number of tracks. So, if you are having the input on the first track of the Turing machine, then we will be able to store other symbols on the second or the remaining tracks of the Turing machine. So, every time when we read or write, it is going to be a tuple of that is symbols, like maybe when you are having 3-track Turing machine, then it is possible to read 3 symbols at a time, and also it is possible to write 3 symbols at a time onto a particular that is cell, I mean that is a vertical that is column of that is cells. So, we had also seen that the finite control with the storage, where it is possible to store more than one symbol, that is one or more number of symbols into the finite control. So, that they will be used for that is verification on later stage. Maybe in the first step, if you are reading a symbol, you just hold it on the finite storage, and then after there is some number of positions, if you want to verify whether the symbol what we have stored is same as the symbol being scanned now, then we can make use of the symbol which is already there in the storage. So, finite control with storage, then multiple tracks. So, those things are the extra features available as far as the Turing machines are concerned. But whatever be the features we have included, like the finite control storage, or it is going to be the there is multiple number of tracks on a Turing machine. But if you look at the actual language recognition power of the Turing machine or the computational power of the Turing machine is concerned, so we do not find out any change. Still, the language of the Turing machine is going to be only recursively enumerable. So, whether it is going to be a Turing machine with one number of tape or one tape with multiple tracks, or whether it is going to be multiple tapes of the Turing machine, or with finite control storage or one storage or any number of storage, but they are all facilitating as far as the design of the Turing machine is concerned. But in terms of the language recognition power, they do not have any that is additional power just because of those features are introduced into the Turing machine. As far as this episode is concerned, we have a Turing machine construction for a new language called that is of the pattern that is WCW. So, where this W belongs to anything like 0 or 1 any number of times. So, it looks like the pattern that is some string is there, some W is there, then there is a separator available, and then followed by whatever the pattern available in the beginning, it is supposed to be repeated. A similar kind of language is going to be the WC then W reverse, where the first part of the string is going to be available as the second part of string, but in the reverse order. So, that language already we have proved as context free language, and it is possible to come up with a context free grammar for that language. Since it is going to be a context free language, it is possible to even come up with a push down automata. So, it is very obvious that the first part of the string will be pushed onto the stack, and on seeing a separator, then we will be verifying whether the second part of the string in reverse is same as the first part of the string, just by popping there is one symbol for each input symbol from the second part of the input. So, if there is always a match available for the current symbol available from the buffer and the top stack content, then we will continue further. Whenever we find there is no match, then we will say the string is not of the form WC W reverse. Otherwise, we will find whether the stack becomes empty. At the same time, if the input is also becoming empty, that is input buffer is also becoming empty, then we will claim the string is of the form WC W reverse. But that language is more simpler than the language that is WCW. Here the pattern is one string followed by a separator followed by the same string in the same order. So, strictly it is not possible to recognize such a language with the help of there is a context free grammar, or it is with the help of a push down automata. But it is possible to construct a Turing machine for recognition of the language that is WC, that is W. Because the Turing machine is having a tape, we can simulate even the behavior of a stack or behavior of a queue or anything is possible. But whereas in the case of push down automata, only we can simulate a stack, because it is a stack is already available. The behavior of stack can be very easily that is obtained, whereas the behavior of a queue cannot be obtained. So, in this language it is required to have the behavior of a queue rather than a stack. So, we can't recognize this language, that is WCW, using a push down automata, but we can go for a Turing machine. With the help of the Turing machine, it is possible to recognize the language WC, that is once again W. So, the Turing machine facility what we are extracting for the recognition of this language, that is WCW, is a Turing machine with one tape, but we are having multiple number of tracks. So, one track can be is actually one track is mandatory to hold the input, and the other tracks they can be used for normally for checking of symbols. Checking of symbol, I mean, so what symbol has been already verified and what is yet to be verified. So, when there is a need for differentiating what are the symbols already we have processed or already we have used, and what are the symbols yet to be processed or yet to be used. So, even in the absence of the additional track, it is possible to recognize these strings, but the issue is we need to either that is delete those symbols which are already used, or we need to replace those symbols by a different symbol, so that we will be able to differentiate whether the symbol has been already processed or not. At the final, that is the end, what we will be losing is the input will not be there as in the that is the initial stage as far as the tape is concerned. So, it is not possible to recover, or it is difficult to recover the input after processing the string, but that issue can be completely solved provided if you have multiple number of tracks on the tape, and those tracks can be used for denoting whether a symbol has been already processed or not. We can make use of any special symbol, maybe an asterisk or a tick mark or some plus, something like that, in order to that is say whether a symbol has been already processed or not. So, if you want to have that kind of marker symbols, strictly we want to have an additional track, so that these marker symbols can be stored to differentiate whether a symbol has been already processed or not. So, we want to have a Turing machine with more than one track on the same tape, so that we will be finding it is very easy to design a Turing machine for the recognition of the string, that is WC followed by W. So, here is the construction. So, we have actually we are having a multiple track Turing machine, and this language is going to be the non context free language, and one of the track is used for holding the data and the other one is used for holding the marker symbol. So, the second track, which is actually used for holding the marker symbol, which says whether a symbol has been already processed or not, that is it is used for checking of each symbol as we use. Once processed, then we will say it is marked, otherwise it is not going to be a marked symbol. So, now look at the components of the various there are various components of the Turing machine. First of all, we are having the set of states, then we have the input alphabet, that is our sigma, then the tape alphabet is there, gamma is there, then del, the transition function, which is actually that is having all the transitions which are needed for the recognition of the string of the form, that is WCW. So, then we want to have what is the starting state, another one is going to be the final state. The starting state here is it is actually Q1 alone, but since we are designing the Turing machine with multiple number of tracks, it is required to hold the track, that is both the tracks, that is the vertical column from both the tracks. So, we are having that is q1 on the that is going to be the, actually this is the starting state with the state and the finite control storage. The storage is here, it is called that is kept as blank initially. So, it is blank, and now look at the that is your the final state. The final state, when you are going for that, it is going to be q9 is the final state, and then we find the q9, there is a storage on the finite control is also going to be the blank. So, actually these two can be derived only after the design of your Turing machine is concerned. So, the starting state here it is q1 comma blank with the finite control storage having nothing, and the final state is going to be q9 and there is b. So, once again we find that nothing on the buffer. So, now we have to study that is every component of the Turing machine, that is one by one in the coming slides. So, here is the description for the set of states. So, Q is a set of all states, and the states are included, actually states are the finite control, they are used for holding one symbol in the memory or in the storage. So, it is going to be either that is q1 0 or q1 1 or even q1 blank, and once again it is q2 0 or q2 1 or q2 blank, and finally there is totally we are having 9 number of states. So, that will be known after at the end of the design of the entire Turing machine. So, we will be having all these things. So, it is always going to be a pair of information, one is the state and another one is what is going to be on the storage or the finite control storage. It can be either a 0 or a 1 or a b. Then when you are looking at the tape symbol, it is going to be the gamma. So, the tape actually it is not going to be a that is a single track tape, it is going to be a 2 track tape. So, every time whether it is going to be read or write, whatever it is, then we will find 2 symbols will be simultaneously read from the that is tape, that is on the column base. So, from the first track of the Turing machine pointed by the current pointer, the finite control, we will read one symbol, and from the same position but on the second track we will read another symbol. So, here we look at the content, that is it is once again going to be a pair of symbols, either it can be a b followed by a 0 or a b followed by a 1 or a b followed by a c or a b followed by b. It means that we keep the first track for the marking and the second track for that is symbols, that is from the input. So, the second track is going to have 0 or 1 which is part of your w, then c as a separator and b as the end marker. So, it is going to be left end or going to be the right end, we will be marking with the help of the symbol called b. Then we have star in the first track. So, once again on the second track we will be having the same, that is w, c, w will be available as far as second track is concerned. So, if the first track has a star on the current cell, then it denotes that the concerned symbol or the corresponding symbol on the second track is already used or processed, and if it is not having a symbol that is star on the first track, then it means that the current symbol which is there on the corresponding second track of the Turing machine is not yet processed. So, the description here where star is used for checking of symbols of the first and second group of zeros and ones. So, now look at the one inputs, that is input alpha, that is your sigma, which is going to be the set of input symbols. Once again it is of the form like b comma 0, it is the first track may have a blank, on the second track it may be a 0. Once again the first track may have a blank, the second track it may be a 1, and the last one is the first track is going to be blank and the second track we are having C. So, if you are having that is the input alone, then there is no question of having the star or any other symbol. So, as far as the input is concerned, we keep the entire that is first track of the Turing machine as blank. Only on the second track we may have symbols like 0 or 1 or a C, where C is separator denoting the separation in between the first part of your WCW and the second part of the same string. So, these are the actually the first 3 components. We have the set of all states, then the set of all tape symbols which will be there as far as the progress of our entire recognition process is concerned, and then we will be having what is going to be the input alphabet, that is the sigma. So, now the only important that is remaining component is going to be the transition function. So, the transition function we call it as del, and the various rules required for the transition function are here it is explained, that is one by one. So, when you are looking at the transitions, so normally we will be starting with the starting state of the Turing machine, and then we will write the various steps of the Turing machine, and finally we will go for the final state. If you are able to reach the final state of the Turing machine, then we will say that the process, that the recognition has been accepted. Let us see the various transitions, but after a short break. So, welcome back. We are going to see the various transitions required for the construction of a Turing machine, where we have which is for the language called WCW. Let us see the first transition. So, we are having the transition function del, and the starting state is q1 comma blank, where the state is q1 and the finite control is not having anything. So, it is going to be blank. Then the input is concerned, we are having two tracks tape. So, it is going to be the first track has B and the second track is going to have a small a. It means that the first track has nothing, because it is very first transition we are looking for. There is no question of having a symbol already marked. So, definitely it must be an unmarked symbol or unchecked symbol. If it is an unchecked symbol, the first track is going to have a blank. The second track, we have the very first input symbol, let it be A. So, now the idea here is, or what transformation we are looking for this particular configuration is, since it is going to be the very first symbol we are reading from the input, you just record it into the finite control storage, and once recorded we must say that the symbol has been processed or the symbol has been recognized. It should not be once again that is considered for mapping with the second part of the string. So, how do you differentiate whether a symbol has been marked or not is with the help of that is asterisk. So, the asterisk is going to be stored onto the first part of the first track of the Turing machine corresponding to the cell that is for A. So, we are going for the change, that is the updation is the first track you put a star there, and the second track you just leave the input as it is A, and now we have to say that is what is the state we will be after recording this or after doing this. The state we will be going for, that it can't stay back in the same state q1, because we need to differentiate whether a symbol has to be recorded or not recorded. As far as state q1 is concerned, it is meant for recording the first unchecked symbol, and if you still on the same state, it will once again record the second symbol, but that should not happen. So, there is a need for a change of state. So, we go for q2 and it is required to record the symbol that is A. So, which is stored onto the finite control. So, the new state is q2 comma A. So, as far as the original state is concerned, the storage has nothing, and the resulting state is concerned, the storage has the symbol what we have just read from the input tape of the Turing machine. So, once it is recorded, now we have to go for, that is skipping all the remaining symbols until we find the second part of the string with an unmarked symbol or unchecked symbol. So, it is strictly required to make a right move. So, q2 comma A comma star comma A, that is going to be a tape content, then where do we have to move is, it is going to be a right move. So, it is going to be R. So, that is the first step. So, now as far as the second stage is concerned or second state is concerned, it is actually meant for skipping all the unchecked symbols which are following the current position. So, when you are having that is q2 comma A, the next symbol which is on the track, that is your Turing machine tape, is certainly going to be an unchecked symbol. It is going to be B, and small b is any symbol. The reason why we are differentiating this A from B is, so this symbol is the one which we have recorded as far as the finite control storage is concerned, whereas this B is any symbol which we read from the tape. So, we do not disturb anything as far as the tape is concerned. So, we will keep this B as it is, and even the finite control storage we should not go for updating, because that is the storage having some symbol, that is very first symbol which is checked recently, which should be combined with the second part of the string, so that we will be able to ensure that the string is of the form W followed by C followed by W. But only thing is we have to keep on moving towards right. So, now how long we will continue this is, as long as we find more symbols which are unchecked in this first part of the string, we will be in the state called q2 and we will keep moving towards right. So, at one stage we will find that the second track of your Turing machine or in the input we will be having a C, because that is separated. the Q2 is doing the job of skipping, that is all the symbols until we find a C. So, once we find a C, you do not disturb the first column, that is your first track of the corresponding that is position, that is B, you just leave it. Now, there is a need for, that is a change of state. The reason why we go for a change of state is, after seeing that is the C, the kind of symbols that we have to skip is only those symbols with which are checked off already. So, we have to find out the symbols which are checked off. As far as the previous state is concerned, that is before seeing the C, we should skip only the unchecked symbols, but after seeing that C, we should skip only the checked symbols. So, that is what we make a change on the state. So, Q3, but still we will not change the content whatever we have stored as far as the finite control storage is concerned. That is going to be our A, and keep moving. So, that is what on finding C, keep moving right, but with a new state saying that hereafter you have to skip only the checked symbols. So, now we have the transition for skipping all the checked symbols. So, we are having that is del of Q3 comma A, and what the symbol we are having is going to be the that is star B, which is a checked symbol, and now you just skip on those things. So, without disturbing anything on the second track of your the input is concerned, or even the state of changes change that the state is concerned. So, Q3 comma A and star comma B, but it is going to be a right move. So, now how long we will be on the state called Q3 is, as long as we find the checked symbols, we will be in the state called Q3. So, now we are making use of the same thing like Q3 comma A with the B comma A. So, that is going to be the new thing. So, as long as we are finding checked symbols, you keep moving towards right, but after some stage definitely we will find an unchecked symbol, because we are looking for a that is match. So, if the first unchecked symbol after skipping the checked symbols is identified, then it should be same as the symbol whatever we have on the storage, that is in the finite control storage. So, the finite control storage has the symbol called A, and as far as the new symbol which is going to be the that is so far there is unchecked symbol, that is A, if both are same, then we can say that there is a match for the most recently stored symbol onto the finite control and the very first unchecked symbol from the second part of the string. So, if they are same, then we can do like we can skip the symbol available on the, or we can completely clear the symbol available on the storage, and the symbol A must be marked as checked symbol. So, you are making the storage as blank, and then we are marking the symbol as checked, and there is no need of once again moving towards the right, because this is the position we have to go for once again repeating the same process. The first symbol has been identified, then we have that is skipped all the that is remaining symbols, unchecked symbols, we have seen a C, then we have skipped all the checked symbols, then we have identified what is the very first unchecked symbol from the second part of that, we have compared that whether they are same or not. Since they are same, we have made that symbol as checked symbol, then now we have to come back. So, we will be making use of the remaining few transitions for coming back to the previous position or into the that is initial state, that is for Q1. So, here we are making use of the transitions like we are having del of Q4 comma B. As far as the move from right to left is concerned, till we find that C, we have to skip all the checked symbols, and after we find the C, we have to check only the unchecked symbol, or we have to skip only the unchecked symbols. So, as far as Q4's job is concerned, we have nothing on the buffer, because already we have matched that symbol. So, it is not needed to anymore remember the symbol whatever is then the storage, and there is skip all the checked symbols. So, star A, we will keep it star A, move towards left, keep on that is staying in Q4. But what will happen when we find a C? So, from Q4 if you find a C, then once again there is a need for changing the state, because after finding the C, when you are moving from right to left, it is required to skip only the unchecked symbols. So, that is what a change of state is mandatory as far as this particular context is concerned. So, Q4 comma B becoming Q4 5 comma B, and definitely we will find unchecked symbols. So, B there is a blank on the first track, C we just leave it, keep moving towards left. So, at this stage we have to now decide whether it is going to be an accepting configuration or it is going to be once again repeating the same job or not. As far as the current context is concerned, if we find the next symbol, that is symbol which is just on the left of C is going to be a checked symbol, then it is going to be the end. Suppose if the symbol which is available on just left to the C is an unchecked symbol, then once again we have to find out the very first unchecked symbol from the first part of the string. So, for that only we are making use of this particular transitions. So, it is as far as Q5 is concerned, no storage, a blank which means an unchecked symbol, you keep moving towards the left with a new state that is Q6, no storage, and keep that symbol as unchecked symbol. So, move towards left. So, this Q6 will keep on move towards left without disturbing anything on the that is your buffer as well as on the that is your tape, and what will happen when you find a checked symbol. So, Q6 if it finds a symbol that is checked, then it will simply enter into the initial configuration of the Turing machine by moving from the current position to the right. So, once we make a right move from the current position, that is with star A on the tape, we will find a symbol which is unmarked, and you have to stay in the state called the Q1, which is going to be starting state. So, we have seen so far there is 10 number of transitions, and all these 10 number of transitions once we do in the same order, we will be able to that is form a cycle which will find a symbol from the first part of the string and find the corresponding symbol from the second part of the string. Both will be checked and we will continue the same process as long as matching symbols are there. So, now the question is what will happen suppose if we find a move, or when you are making a left move from the C, there is a checked symbol rather than unchecked symbol. So, in that case what we mean is all the symbols from the first part of WCW have been verified or checked. So, now we have to move towards the right and skip all the checked symbols and keep on moving towards the right, and we are expecting a blank rather than a checked symbol, that is an unchecked symbol. If you find any unchecked symbols from this particular context, then it means that the first part of the W and the second part of that string, that is your first part of WCW and the second part of that are not going to be same. But when you are looking at this particular configuration, that is from your Q7 comma blank B comma C, you are going for Q8 B, then B and C, and once again from Q8 skip all the checked symbols, stay back in this state called Q8, leave them as checked symbols, keep moving towards the right, and now we will be looking for a configuration where we will be having that is your B and that is B. It means that the tape has no more that is unchecked symbols. So, when this particular configuration is reached, we will be entering into a state called that is Q9. So, this Q9 will tell you that is we have reached the final state of the Turing machine. So, here is the description of the input. What will happen? We are having the initial configuration that is 101 with the C as the separator and once again 101. So, after seeing that is two symbols have been checked, we will find that is 1 checked, 0 checked, and the corresponding 1 is also checked here and 0 is also checked. So, what remains is this 1 with the blank on the first track saying that this one has not been checked, and here also the 1 on the rightmost end of the tape, since a B on the first track corresponding to this particular cell is going to be is there, we say that it is also a symbol which is not as checked. So, now here we are having there is Q1 comma B comma 1 which will record this 1, move towards right till we find that is your C, then once again skip all the checked symbols and we will reach this particular configuration or this position where we have a match. The one stored here in the finite control is same as the one we are reading, which is so far not marked, and now it is going the same process. You just mark it, come back. From here we find there is no more unchecked symbol after that as far as this particular configuration is concerned, and we can go for accepting this configuration because all the symbols from the first part have been marked, and similarly all the symbols from the second part are also have been marked. So, we will go for the accepting configuration as the input is of the form WC and that is W. So, with the help of the multiple number of tracks, we will be able to solve this problem, that is your recognition of the pattern W C followed by W without disturbing the input. That is a very important thing. The same thing can be solved even in the absence of multiple tracks, but we will be losing the input that is at the end, or we need to have more number of steps in order to restore the actual input, so that we will be able to have the input what we have verified as where it is going to be of the form W C W or not. So, to summarize, the problem like W C W, or even if it is going to be W C, that is W reverse. So, these strings can be very easily verified provided we have Turing machine with multiple number of that is tracks. So, similar kind of problems here we are having are there is one thing like that is a W C W reverse, where the first part and second part are similar, but except the reverse of the there is first part is going to be second part. And there is another string that is 0 power n followed by 1 followed by 2 to n, that is 2 times the number of ones available in the pattern is going to be 2 times the number of zeros available in the pattern. So, when you are checking of the symbols, you check off 1 0 and go to the right and check off 2 number of ones rather than one, that is only 1 1. So, every time for each 0 2 number of zeros or 2 number of ones will be checked. So, that is going to be the issue, and here it is going to be 0 power n followed by 1 power m followed by 2 power n plus m. So, you first you check a 0 and go, that is, and skip all the remaining zeros, all the ones, and check 1 2, then come back, find out either first, that is unchecked 0 or unchecked 1, check the symbol, very first symbol which is so far not checked, check it out, then move towards the right. Whether we have seen the most recently unchecked symbol is 0 or a 1, but the next symbol to be checked is going to be a 2. So, for every 0 we will check 1 2, and similarly for every 1 we will check a 2. So, what will happen is, if the string is certainly of the form 0 power n followed by 1 power m, then followed by a 2 power n plus m, since we are checking for every 0 a 2 and for every 1 a 2, at the end, that is after recognizing, that is after checking all the zeros and all the ones, if you find that exactly there is no more 2 yet to be checked, it means of 0 power n followed by 1 power m followed by 2 power 2 n plus m. If there are more number of zeros 2's, or if there are less number of 2's, then we will not be able to reach the final state of your Turing machine. So, these kind of problems may be asked as far as the particular there is multiple track Turing machines are concerned. So, with this I conclude this episode. Thank you all.